We're now going to continue with the second section of probability. So please open up your study guides to probability 2. Now let's begin with the notation for probability. The notation we use for probability of an event is the capital P followed by, in parentheses, the event that we're talking about. So this is read as the probability of event. The probability that event A will occur is given by the following formula. The probability of event A is equal to the favorable outcomes divided by the total outcomes. Now this method for calculating probabilities is only appropriate when the outcomes of the sample space are equally likely. When we have a sample space and the outcomes in the sample space are equally likely to occur, the probability of an event occurring is equal to the favorable outcomes divided by the total outcomes. Now let's talk about experimental probability. Some probabilities are calculated or estimated through experimental efforts. An experimental probability is the relative frequency at which a chance experiment occurs. Now recall, frequency is count, relative frequency was the percentage of observations. So in experimental probability, the relative frequency at which a chance experiment occurs is our experimental probability. Suppose we roll a fair die 600 times and we obtain 112 fives. This would lead to an experimental probability of 112 out of 600. However, we do know the theoretical probability would be 1/6. Although the experimental probability is not the same as the theoretical probability, it is quite close. The more times we repeat the experiment, the closer our experimental probability will be to the theoretical probability. Now, we do know the theoretical probability of many events. However, there are some that we do not know the theoretical probability to, so we have to estimate their probabilities by performing and conducting an experiment. And once we do that, we can get experimental probabilities associated with that. And we do know that the more times we conduct or perform this experiment, we are going to get closer and closer the experimental probability to the actual theoretical probability. This concept leads us to the law of large numbers. Now, the law of large numbers is a very important concept in probability. The law of large numbers tells us that as the number of repetitions of a chance experiment increases, the difference between the relative frequency of occurrence for an event and the true probability approaches 0. So, law of large numbers basically tells us as we keep repeating a chance experiment, we repeat it over and over again, then the relative frequency of occurrence for an event based on this theoretical probability is going to be about the same as the true probability itself. So they approach each other. In other words, their difference approaches 0. Now we have several rules for basic probability, and let's begin by talking about rule number 1. Rule number 1 is our normality rule. The normality rule states that the probability of any event occurring is always going to be between 0 and 1 inclusively. That is, the probability of event A occurring is between 0 and 1. And we do include 0 and 1 because there is a chance that the event A will never occur, and there's a chance that event A will always occur. Now, why the name normality? A measure is said to be normalized if it is put on a scale between 0 and 1. This is the reason for the name of rule number 1, normality, because we are putting a probability on a normalized scale between 0 and 1. Rule number 2 is our rule for certainty. An event that is sure to happen will always have a probability of 1. That is, the probability of a certain event is equal to 1. Often, the Greek letter omega is used to represent certainty, so the probability of omega is equal to 1. Rule number 3 deals with the probability of complements. Now, the complement of an event is basically the opposite of the event. That is, the set of all outcomes of an experiment that are not included in an event. The complement of an event A is written as tilde symbol A, which we read as not A. We can also read it as A complement with the superscript C as well. So the probability of event A occurring